The fraction currently on the screen is an extremely close rational approximation of the ratio of the length of a Draconic month to the length of a Synodic month. This implies that 223 Synodic months is nearly the exact same amount of time as 242 Draconic months, approximately 18 years and 11 days. Why is this amount of time important? Welcome to TwoLambdaPlusBlack. I am Heirua. Recall from the previous video that a Draconic month is the time from one ascending node of the moon's orbit with respect to the Earth's orbital plane to the next, and that a Synodic month is the time from one new moon to the next. Now, recall what the conditions for a solar eclipse are. The moon needs to align between the sun and the Earth, or in other words, given the inclination of the moon's orbit, a solar eclipse occurs if and only if a new moon coincides with the moon's ascending or descending node. Or in other words, if a solar eclipse occurs, then in another 18 years and 11 days, in almost all cases, there will be another solar eclipse with a nearly congruent path traveling through the same latitudes. But it's actually not just that, because 223 Synodic months is not just nearly exactly 242 Draconic months, it's also nearly exactly 239 Anomalistic months. Recall that an Anomalistic month is the time from one apogee to the next, so a whole number of Anomalistic months later, the moon is at about the same distance from the Earth as it is at a given point in time. So, the next solar eclipse is in fact nearly identical to the previous one. It is also nearly identical in its width. If Earth was tidally locked to the sun, then the next eclipse would be identical, differing only by the margin of error. But the Earth rotates substantially faster, so the eclipse does have a longitudinal displacement from the previous eclipse, and doesn't land at the same place on Earth's surface. The set of eclipses 18 years and 11 days apart is known as a Saros Series, and the period of time 18 years and 11 days itself is known as a Saros. Over the course of about 1,300 years, a Saros series produces first partial eclipses, then total hybrid or annular eclipses, peaking at some point and then retreating, eventually back to partial eclipses again, all spaced one Saros apart. The gradual rise and fall of a Saros series over 1,300 years is attributable to the slight margin of error between 223 Synodic months and 242 Draconic months. Saros series make finding the approximate dates of future solar eclipses fairly simple. Take all the days, 18 years and 11 days to the future of an already existent solar eclipse, and apply a longitudinal translation for the path of the eclipse, occasionally retiring a Saros series or beginning a new one. But that's not all the prediction a Saros series has to offer. Notice that 223 is odd while 242 is even. So, halfway through a Saros, the moon will still be at the same node as at the ends of the Saros, because a whole number of Draconic months have passed, but 111.5 Synodic months have passed, so the moon is now synodically halfway through an orbit. Or in other words, on the other side of the Earth with respect to the sun. So we have a lunar eclipse. A lunar eclipse is the coinciding of a full moon with the moon's ascending or descending node. So one could find a lunar eclipse half a Saros after a solar eclipse, and themselves have Saros series of eclipses separated by 18 years and 11 days. Saros series are an example of the power of approximation. The coincidence of a Synodic Anomalistic Draconic alignment at 18 years and 11 days makes predicting future eclipses much more doable to a high degree of accuracy when more exact calculation would be a lot more tedious. Many of the most beautiful moments in computation are like this, when a small available approximation allows for a massive amount of simplification. Thanks to my patrons for funding TwoLambdaPlusBlack. You can join them at patreon.com/Heirua. There is a link in the description. And as always, remember to love the night.